Hi class, this is Balancing Chemical Equations. It's covered in your book on, 172 through 181. Okay, so when you see a chemical equation written with words like hydrogen and oxygen yield water, number one, we need to write each formula correctly, balancing charges, remembering diatomic molecules. We're going to take each small formula and balance it with small subscripts. So, here we have hydrogen. We write the symbol for hydrogen. And we have oxygen. Whoa, I hate it when it does that. Oxygen is O, unless you have your zoom on. Good night. O, and yields is an arrow. Yields separates our reactants, like our ingredients, from our products. Now, you've learned water is H2O. Why is that? Because oxygen is group 6, so it needs 2 more to make 8. Its charge is -2. Hydrogen is in group 1, so its charge is +1. We need 2 hydrogens to balance the -2 oxygens. So we get that subscript 2. Back in our reactants, we learned that hydrogen and oxygen are both diatomic. So every time we write those by themselves as an element, they have a 2 beside them. They always come in pairs. Number 2, we count the atoms on each side of the yield sign to balance the equation. Just like in algebra, the left of the equal must equal the right of the equal. This time, the left of the yields equals the right of the yields. This is the law of conservation of mass, saying that mass that you begin with cannot be created or destroyed. It has to be the same atoms at the end of the equation. When we count, we're going to draw a line separating our reactants from our products right underneath the yield sign. You'll list all of the atoms that are involved in your reaction. This reaction only has hydrogen and oxygen. We're going to count. We count only 2 hydrogens on the reactant side, and over here we have 2 hydrogens on the product side. Our oxygens, we have 2 reactants, and over here we have 1 oxygen in our product. That tells me it is not balanced. I need more oxygen in my products to make this a balanced equation. So in number 3, I balance my big equation with big numbers, the coefficients. Coefficients are only allowed to be in front of the whole formula. They cannot be stuck in the middle of the formula. So I need double my number of oxygens. I cannot put a 2 here in the middle of water. The 2 must go out in front. That means that I have 2 molecules of water. Therefore, I have 2 oxygens, 1 in each molecule. So I change my count of oxygens to 2, but I've also changed my hydrogens. Now I have 4 hydrogens. In my reactants, my oxygens are balanced, but my hydrogens are not. I can double my number of hydrogens with a coefficient, and that changes my count of reactants to 4 hydrogens. Now everyone is balanced. All right, let's try another example to use these steps. Here we have carbon and oxygen yield carbon dioxide. So we write the symbol for each element. We have carbon plus oxygen yields, and carbon dioxide makes it simple. The prefix tells us to write 1 carbon, and di means 2 oxygens. If you want it to balance the charges, the oxygen is -2. That gives us -4. And the carbon is in group 4, so that's positive 4. Is carbon diatomic? Carbon is not diatomic, but oxygen is, so it needs a subscript too. Now all my little formulas are balanced, each with little subscripts. It's time to count to see if my equation, my big equation, is balanced. I list all of the atoms. In this equation, I only have carbon and oxygen. On the reactant side, I have 1 carbon, and on the product side, I have 1 carbon. On the reactant side, I have 2 oxygen, and on the product side, I have 2 oxygen. My carbons and my oxygens are balanced, so I do not have to use coefficients to change the equation. It is balanced as it is written. All right, let's try another example. Carbon tetrachloride. How do we write that? Well, I'm glad you asked.